So this is week 1, day 1. We're going to look at standard and expanded notation, rounding, and estimating, different exponential notation, and order of operations. So that will be our objectives for this video. There will be 3 parts, but all in one video. So let's talk a little bit about place value. Notice where your decimal point's located. Everything in this area here is what we will be discussing for probably the first couple of exams. So where everything's going to be whole numbers till we get to our decimal notations. Here you'll see anything in red is a place value. So if I ask this 1,234 and I have the 4 underlined, I'm actually talking about the ones. I'm not talking that there's 4 ones. I just want to know that that's the ones place. Take this one here, and I've got 1,234, and I'm looking for this place value. That is the thousands. You don't have to put 1,000s because the 1 just represents how many thousands are identified. Standard notation and expanded notation. So you'll have the differences here is you'll have, let's say, 534. This is what we would call your standard notation, and 5 hundreds, comma, 3 tens, 4 ones. So this would be your expanded notation. Notice everything is expanded out into words by the place value. So 725, this is again standard notation, and you see every 100 ones, tens to hundreds, ones, tens, hundreds, all the way to thousands. There's your standard. And then the expanded, like I said, is you're just going to write it in words based on the place value. So 725, I should see the 5 ones, tens, and hundreds. And since I'm asking to expand it, I would want to know how many ones I have, how many twos, and how many hundreds. Which is different when I'm asking just for the place value. So if I had 725 and I'm looking at this and say, what's the place value? Well, that would be hundreds. And then back to these, 1,248, I've got 1,000, 2 hundreds, 4 tens, 8 ones. So we're expanding it with words by place value. You can also look at it another way, where I have 7 times 100 in parentheses. That just means that I have 7 groups of 100, 2 groups of 10, 5 groups of 1. 1,248 just means 1 group of 1,000, 2 group of 100, 4 groups of 10, 8 groups of 1. So if I want you to expand this one, this would be 5 hundreds, 0 tens, and 8 ones. Let's look at C. We would say 200,000s, 3 10,000s, 5,000s, 8 hundreds, 8 tens, 8 ones. Next we have items that would be going from expanded notation to standard. So now you're looking at each of the place values. You get 2 10,000s. So that would be 20,000. You get 3,000, so that would be 3,000. So we're showing 23,860 for part A. For part B, 500,000 Notice we don't have any 10,000s, so that would be a 0. 6,000s, 0 hundreds, 5 tens, 7 ones. So that would be, there's part B. And then C would be 4,623 for 4,000s, 600s, 2 tens, 3 ones. And then finally, we've got 500s, 8 tens, 4 ones. So all of those new for A through D would be your standard form. And then we've got things called periods, which are different than the commas, but the periods just show where the comma should be placed. You should have 3 place values and then a comma. So you got your ones, tens, hundreds, comma, thousands, 10,000s, 100,000s, comma, millions, 10 millions, 100 millions, comma, billions. And so you see that the comma is placed in here. So if I'm asking what's the place value of the 2, well, then you're thinking your hundreds, your thousands, your millions. So that 2 here would represent the 200 million place value. The United States would have 3 place values, a comma, 3 and a comma, so we'd be at 313 million. So you got some practice. You know your links in the, when you go into the folder, click on the links for the homework practice or extra video help. Objective number 2, we're looking at different rounding procedures, working with compatible numbers in order to do estimates. So for rounding, when I say nearest tens, I'm looking right here. I'm looking at that number, this number. All of these, I'm thinking about the nearest tens. So on a number line approach, you've got that 137. So we know that it's going to be between 130 and 140. And we know in the middle is 135. So 137 is going to be somewhere here. So notice that it is closer to 140 than it is to 130. So this would round to 140. 235, same idea with your number line. You'll have 230 and 240. And 235 is in the middle. So 235 is actually right there. It's an equal amount away from 230 to 240. So our general rule is that when it's on the halfway point or ends in a 5, we are going to round that up to 240. 473, remember you're looking at the 7 tens, so this 3 will not round it up. So it will actually be closer to 470. And then 684 is between 680 and 690, and the 4 would not round it up, so it would be at 680. So those are your rounding to the nearest tens. Nearest hundreds would be between, would all be all your numbers here. So it'd be between 600 and 700. With 650 falling in the middle. 641 would be somewhere over here. So it's closer to 600 than it is 700. So the nearest hundreds, that would be 600. This would be between 700 and 800. And so this would be 700, or excuse me, around 800. This one is 800, 7 tens. So this would actually round up to 1,900. And then 9,325, we're looking at the 2 tens, and it would not round it up to 9,400, so it would be 9,300. Again, you're looking at, identify the place value that's discussed, hundreds. So I'm going to identify all my hundreds place. And then I want to look to the right of each of them. And if that number is larger than 5 or larger, I know I'm going to round up. 4 is not. It's going to round down to 600. 5 is, it'll round up to 800. 7 is larger than 5, it'll round up to 1,900. 9,325, the 2 will not round it up to 9,400, it will stay at 9,300. And then the same with the thousands, you just identify your thousands spot. 7,896, that 8 will round it to 8,000. This 4 will round it down to 8,000. This 300 will round that down to 19,000. And then the 600 would round this up to 122,000. Front-end estimation. So you take all of your numbers here, and I just want you to look at the largest place value, which is tens. So the 8 would round the 7 to 78 would round to 80. 49 would round to 50. 31 would round down to 30. 85 would round up to 90. And then I want you to go ahead. What you've got are just multiples of 10. So I've got 13, 14, 15, 16, 250 would be the front-end estimation sum here. 652, I'm looking at all the 100s. So 652 would be 700. 688 would be 700. 238 would round down to 200. 164 would round up to 200. So that's 14, 15, 16, 17, 1,800 as a front-end estimate. With subtraction, it's the same idea. I'm looking at the largest place value, which is thousands, so I'm looking to the 200s and the 700s. Well, the 2 will not round it up, so it'll round down to 9,000. 6,700, the 7 will round it up to 7,000. So I subtract. Got some easy numbers to work with. 2,000 is my estimate. Here, a couple of ways to look at this. You could look at the thousands and say, well, the 2 won't round it, so that's going to be 23,000. Look here, the 600 would round it up to 1,200, or excuse me, 12,000. So that would be 11,000 as a difference. Or I could go definitely with the 10,000 spot, so I would look at the thousands, and the 3,000s would not round it up, so it would stay at 20,000. And then the 1,000s would not round that up, so round down to 10,000. 20,000 minus 10,000, I get 10,000 as an estimate with the front end idea. Same with division. Our multiplication, 68 times 46, so I want to round 68 to 70. 46 will round up to 50, and so I want you to think of this as 7 times 10 times 5 times 10. 7 times 10 is 70, 5 times 10 is 50. What's 7 times 5? That's 35 times 10 times 10. So 35 times 10 is 350. 350 times 10 is 3,500. There's your estimate of 68 times 46. 437 front end would round to 400. 64 would round to 60. So I'd want you to think 6 times 4 is 24 times 10 times 10 times 10. So you get 24,000 as an estimate. Here, 382,000 we would say would round to 400. 527 would round to 500. I wouldn't want you to go through the standard algorithm here with the place value, 0 times 0, 0 times 0, 0 times 4. Just go with 5 times 4 is 20, and then you're multiplying it by 10 4 times, which creates 4 more place values of 0. So 200,000 would be your front-end estimate. Estimating here, it would be 12,240. I'm going to just leave that as 12,000. And 180, I'm going to round up to 200. So what you have here is 12 times 10 times 10 times 10. That's why you see the 3 zeros. It's all being multiplied by 10. So take your denominator, 200, and it's 2 times 10 times 10. So if you think about this expanded way of showing factors, the 10s divide out, and then you've got the 2 can divide either one of these. So let's say the 2 divides 12, 6 times 10 is 60. So that's the approximate answer of this division problem. So that's the approximate quotient. Here, I would say 65,000. Let's go ahead and go to 66,000. And 345, we'll just say at 300. So these 10s divide out, these 10s divide out, so you're left with 660 divided by 3. 3 will divide 600 200 times. 3 will divide 6 10s 20 times. So what you should have is 220 as a quotient, because 220 times 3 would give you 660. So you've got your practice with estimating, and you've got some different videos that will take you through that as well. And then finally, we want to look at exponential notation and different orders of operations. So when you have something here, you got a family of 4 that goes to a soccer game, and the tickets are $5 each, and the mom buys a $2 soft drink. So one way to incorrectly compute this is to do 5 plus 2 is do the addition first, which would be 7, and 7 times 4 would be 28, and we know that that's incorrect, because 4 groups of 5 is 20, and 20 plus 2 would be 22. So 5 plus 2 is 7 times 4 is 28 would be incorrect. I need to do the correct order of operations, which I need to do multiplication first, then addition. So your steps here, parentheses, brackets, grouping symbols. So you've got parentheses, or you may have brackets. You may see a set with the braces there. You may see a set, and then you might have brackets inside. So then you've got exponents, which come before multiplication, because exponents is repeated multiplication, and you see multiplication becomes before addition because multiplication is that repeated addition. And then these next 2 slides just kind of explain, when you're looking at this, you're going left to right. So whichever comes first. So if you see a 5 times 4 divided by 2, it's whatever comes left to right. So even though multiplication's first, left to right, you're still going to do that. So even if you saw 10 divided by 5 times 4, when you're looking at it left to right, this multiplication or division, they're married together. They're a couple. Whatever comes first, left to right. So in this case, division came first. So 10 divided by 5 would be 2, and then 2 times 4 would give you 8. And it would be the same with addition and subtraction. Whichever comes first when you're reading it left to right. Finally, you've got some exponential notation. So you're thinking, well, how many 4s are being multiplied here? Well, there's 4 of them. So this would be a 4 being multiplied by itself 4 times. So that would be your exponential notation. Factors are just how many numbers you have being multiplied together, and that would be 4. And the factors are 4. So you got a lot of 4s in this problem. What's the base? The base would be 4. The exponent is your smaller number in the right-hand corner next to that number, but that just represents how many times you're being multiplied by 4. Here you've got 3 times 3 times 3 times 3. So 3 is being multiplied. So that exponential form would end up being 3 raised to the 4th power, because there's 4 4 threes there. How many factors are present? There's 4, and the factors are 3. So you can kind of see how it just builds on itself when you ask how many factors and what are the factors. The base is 3. That's the number that's being multiplied over and over. And what's the exponent? It's 4, because that's how many 3's that you see. Here we've got 5 to the 3rd power, which shows 3 factors of 5. This is also called a power. 5 is the base, 3 is the exponent. So let's look at a few of these with order of operations. So I'm looking at A, I'm looking left to right, I see subtraction and then multiplication. So I'm going to do the multiplication first. So 93, take away 14 times 5, that's going to be 50, and 20, that'll be 70. 93 minus 70 is 23. So that's the answer to A. B, you'd have 100 divided by 4 plus 4. So when you scan it left to right, you'll see you'll do division first. So 100 divided by 4 is 25, and then 25 plus 4, you'll get 29. So C, scan it left to right, you see parentheses. So we want to do the parentheses first. So 20 times 5 minus, what's 56 minus 16, and that's going to be 40. So then 20, scanning it left to right again, multiplication first, so that's going to be 100 minus 40, which would be 60. And then for D, we'll work this one up here, scan it left to right. I know I see division, I also see parentheses, so 97 minus 12. So that's going to be 75 divided by 5 plus, what's that, 85. And so then I scan it left to right again. I see 75 divided by 5, which would be 15. And then 15 plus 85 would be 100. And then you've got some practice with the order of operations, and you've got some other videos that'll help you if you need to see a different perspective. You also have this video that goes through what we did. But if you need additional and different examples, those are in the links. And those were the objectives. Standard form, expanded notation. We looked at the different ways to estimate using front end. And then we looked at exponential notation and order of operations.